a lab to work on this week, as well as an assignment to do for the next couple of weeks. I want to talk about what you're going to be doing there, and I'm also going to do a bit of a demonstration for you just to talk about some things. It's some stuff that probably you guys are familiar with. I'm hoping you're familiar with anyway. It's doing some basic stuff using the Windows command prompt. And so I want to demonstrate some of that stuff in the lab and for the lab, and just talk about some things. And if you have any questions, or if it looks a little bit strange to you, give you a chance to just make some comments and ask some questions and get some things straightened out. So we'll do that. And so, like I say, since there's kind of two halves to today's class, it might take a little bit longer to complete. And also, I should make a comment that the school, Kwantlen, is still on track to get us back on campus next week. So we should be meeting in person in class next week at 10 a.m. instead of this way. And so from that point on, obviously we won't be doing these online sessions, and they won't be recorded anymore. But what we'll do in just a second is we'll turn on the recording, we'll start today's class, and we will proceed. Okay, so let me say goodbye to you here on my camera, and I will start the recording, and we will start with today's material. All right. Good morning, everybody. This is the second week of Info 1211, and this is possibly notable because this is hopefully the last time we'll be doing this semester, meeting online. Next week, the plan is to start meeting in person on campus and gather together in the classroom and have me talk with you there. So that is next week, January the 26th, meeting in person in the Cedar building, one of the big classroom buildings on campus, on the main floor, the bottom floor, in room 1040. That's at the end of the hallway, sort of towards the exit doors in the Cedar building. And as far as how we sort of comport ourselves, obviously on campus, any indoor spaces, we're required to keep wearing masks, and in the classroom itself, we'll ask to do that. The ventilation situation probably will, there's a bank of windows, and we'll try to keep one of the windows open to get some airflow moving. And of course, for all of us who are in the classroom, we'll be all masked up. I just recently got my double vaccination booster, well, my third shot, I guess I should say, a couple of weeks ago. So I'm good to go. I don't know how many of you guys have been vaccinated as well, but obviously that's the advice from the province, is to get vaccinated so that if we get sick, that we don't get really sick. And so once again, when we get together, please mask up, and we'll try to behave in such ways to minimize the possibility of getting sick. Again, this is going to be on campus next week, and it'll start at 10 o'clock. The room is Cedar, as in the tree. That's the name of the building, and it is room Cedar 1040 on the main floor. Yep, and the idea is that we will be in person for the rest of the semester, unless there is other direction from the administration. Well, you know, it's hard to know exactly what's going to happen. Obviously, 2 years ago when we stopped meeting in person, we thought our break was going to be just for a couple of weeks before we got back together again, and it's turned into 2 years. But hopefully things will have gotten a bit better with the situation, and when we come back, we'll see if that's going to be good. Oh, as far as all other classes, no, I suppose you'll have to talk to your specific instructors and to see what's going on for them. Some classes are just have been designed as online classes, and so those will not be meeting in person. But since ours was scheduled to meet in person from the very beginning, this last couple of weeks has just been kind of to get us through. So again, Next week, hopefully we'll see each other in person for the first time, and you won't be shocked at how good looking I am. You'll just go, wow. And me too. I'll look at you guys and think, wow, you guys are a good looking bunch. Okay, so let's get started with things today, and we'll talk about our material. So once again, what we'll do here is we'll go through this stuff with the slides here on PowerPoint. And I do want to make you aware again that there is more detailed stuff available here. Also on Moodle, it's the notes that you guys should be using to study the material. I will say this, that when you are studying for tests, exams, and whatnot, this is the material that you should be studying. And when you're answering questions on even like assignments, the homework, look to these notes for your answers. This is where the material is. Some of the stuff that I'm going to ask you on assignments, I'll ask you to look outside and talk about your own personal experience and maybe look a few facts up from some legitimate websites. But most of the questions that I ask, if you're being asked about something to do with operating systems, it's probably going to be in these notes. And so I expect that you'll read them. And if you have questions about the content of these notes, you can go ahead and email me or otherwise talk to me about the material. So as I say, in terms of teaching, I'll go through these slides because they're just a little less dense, but the notes will be where the detailed information is. So today what we're going to talk about is a couple of different things. We're going to talk about a little bit more about operating systems principles, again, the theory of operating systems. We're going to briefly go over some of the early Microsoft operating systems, just talk a little bit about their origin and how they've developed over the years. Just the first few of the Microsoft operating systems. We'll talk more about them later on. And also, we will then be talking sort of in the second half of class, more specifically about how to use the command prompt in Windows so that you can manipulate files and do some basic operations in Windows just by typing rather than using the mouse. And so we'll look at that and we'll give you a bit of a demonstration. Okay, so what do we have to say? So this is just a bit of a review from last week. We saw last week that there's 3 things that operating systems should do for us, and that's the case whether we're talking about Windows, about Mac OS, whether we're talking about Android, Linux, or iOS. All those different operating systems, the things that let us interact with a computer or a mobile device. There should be 3 main things about those operating systems in all cases. One, every operating system should make using the computer more convenient or easier. So if using the computer is harder or it's more troublesome, then the operating system is not really that successful, or maybe it's not as successful as it should be. So for example, I think I said this last week that even little kids can use tablets and little kids can use smartphones. It's easy to start an app, it's easy to play a game and that sort of thing. Whereas if you wind the clock back, say 40 years into the early 80s, when computers were like, I don't know if any of you guys know the Apple II computer that Steve Jobs and Steve Wozniak created in their garage in California, 40 plus years ago. That was harder to use. It was just more difficult. You had to be able to type in commands, and you had to do lots of different things to put together the computer system and so on. It was just more difficult. And so operating systems should make using the computer more convenient. Operating systems should also make the computer more efficient. And when we say efficient, we don't necessarily mean faster, although of course speed is important. Speed is usually taken care of by better hardware. So over the last 50 years more, there's just been improvements in the electronics of computers and the actual equipment itself, so that equipment is faster. But when we put that equipment together into a computer system, we still want the computer to use the hardware efficiently. we don't want the available resources of the computer to be used in a wasteful way. So if there's a faster CPU, we want the processing to be done efficiently. We don't want the CPU to be wasting time doing stuff that is not important for it to do. We want it to focus on its jobs. If we have a lot of memory, that's great, but we want the memory to be used efficiently. We don't want the memory to be wasted. We want the memory to be used for the purposes that we want to use it for. Efficiency, as I say, it's not about necessarily doing things faster, but it's doing things in a more resource intelligent way. Just as an example, doing homework, right? It'd be great if you could all do homework faster. That would be great. But to do homework efficiently, that means that you're not wasting the available time that you have. So that's what we're talking about with operating systems. And the third thing about operating systems we talked about was we wanted that an operating system, when it has been developed, that it's not something which has to be totally rebuilt every time you want to make a change to the OS. So if there's needs to change features, add features, patch security vulnerabilities, make improvements to efficiency, and so on, we don't want to have to go through the process of re-architecting an operating system, a process that can take years. We would like to be able to just make changes to the OS on an as-needed basis so that they can evolve over time. Okay, so what we're going to talk about today is a little bit more about this. We're going to talk, last time we talked about the process of, I'll just go back to this here. You might remember that last week I had some pictures of this guy here, Gordon Ramsay, talking about how early computers were inefficient in terms of accessing input and output and storage devices. And we talked about three different approaches that were used over time. One was called programmed I/O, one was called interrupt-driven I/O, and one was called direct memory access. And we talked about how over the course of time, with the changes to the operating systems to incorporate direct memory access, the speed of retrieving information from an input and output device became faster. And so if you looked at this original diagram, the idea was that if a program ever required information to come from a disk, with programmed I/O, you would send a request to the disk module, and the CPU would have to continually check to see if the operation had completed, which wasted the CPU's time. With interrupt-driven I/O, the CPU would ask the I/O module to do work for it, but rather than checking it all the time, it would just trust that when the I/O module was finished its job, it would send a signal back to the CPU saying that it was complete. So the CPU's time is not wasted by having to continually check to see if the I/O's operation is finished. The I/O module will just interrupt the CPU, send that signal and say, hey, I'm done now. And then with DMA, we saw that there was a further improvement, which was that there was an additional piece of hardware called the DMA module. And the DMA module would be responsible for transferring the data from the I/O module into the computer's RAM. Normally, or I shouldn't say normally, but in earlier days, the CPU would have to pause whatever work it was doing to transfer data from I/O to RAM in order to be able to work with it. And again, that's an inefficient use of the CPU's time. When the CPU could be doing other things, it's wasteful to have it just pause to move stuff from one area of the computer to another. So by introducing a new piece of hardware, that reduces the amount of busy kind of work that the CPU has to do. So the CPU can continue doing its important jobs while the DMA module does some of this background stuff. This week, we're going to talk about approaches to doing multiple programs. That is to say, we're going to look at what happens when we have our computer having to do a number of programs together. Now let's for instance call these things program A, program B, program C, and program D. And in the early days of computing, like in the very early days of computing, computers were not able to work on multiple programs at the same time. They were not multitasking as they are today. Computers originally they were single tasking. And if there were programs that had to be run, they could only do them one at a time. So if you look at, if you think about programs A, B, C, and D, this, for example, might be, an accounting program that was running that had to generate some sort of report. This might be like, I don't know, maybe a payroll program that had to run and process employees' timesheets and figure out how much employees had to get paid and, print checks out or something like that. Maybe program C would be some sort of a database program that would go through a series of customer records and generate some reports or something like that. And then maybe program D would be some other kind of program that did some sort of calculation for a company. And as I say, in the early days of computing, you could not put all these programs into the computer and have them running at the same time. The computer would have to be told to do each of these programs one after the other. And in fact, in the very earliest days, we had a situation which was called serial processing. And so a computer would be, first of all, computers would be very expensive, and a company probably wouldn't have more than one computer, maybe two. And in serial processing, it required an actual person, a human operator, to actually take the computer through each of the programming tasks that were supposed to be done. And what I mean by that is that this person would have to find the storage medium on which program A was saved. Now, in the early days, it probably would be like a literal a tape that they would have to find. And they would have to take this tape and they would have to load it into the computer, like physically, manually. They'd have to tell the computer to load the program. Then this person would have to find the data that was prepared for the program to use, and they would have to load that into the computer as well. And then the computer would run the program and spit out whatever output the program was supposed to produce. And then the person would have to notice that this job was finished. They would take the results and do something with it, whatever that would be. And then they would notice, oh, there's program B that still has to get done. And so this person's job would then be to find program B and load program B into the computer, and then find the data for program B and load that into the computer and run that program and produce its output and so on. So there was literally a person that was involved in taking the computer from one task to another. So you can imagine that that's really old-fashioned, and that would be extremely inefficient because, first of all, you're depending on a person to do stuff, and people are much slower than computers. So having this person actually have to locate programs, set them up, take care of results, and so on, that's just slow because people are, as I say, slower than computers, slower than electronics. People also need breaks. So if this person, it's their lunch break, no work could get done, right? Because even if the computer was working on a task, if the computer finishes a task while this person's on a break, the next program's not going to get loaded because this person has to come back from their break in order to carry on. You've got to pay this person, right? That's another downside of things. This is another employee that you have to take care of, and so that's inefficient from kind of a cost standpoint. But serial processing, as we call this, that was just the way that computers worked. There were no other options, and so in order for this for any computing to be done, this was the technique. So serial processing, quite inefficient. So over time, again, the efficiency was addressed by an operating system, and someone said, we could make this faster by instead of having a person in here doing all this work of taking the programs A, B, C, and D and plugging them into the computer one at a time, what we'll do instead is we will design a program, and we'll load that program into the computer. And this program will be called a monitor. Now, I know that's kind of a strange name because monitor, you probably think of the screen of your computer, but in these days, a monitor meant a piece of software, and it still is used in this way today, but maybe not quite so frequently. The monitor is a piece of software which basically replaces the job of this person. And how it does that is that the monitor is a program which allows someone to load up multiple programs into the computer. Well, maybe what I should say is that it allows someone to create a queue. By a queue, I mean like kind of a line of programs that are ready to take their turn in the computer. And so you can imagine that these programs that have to be executed form this queue. Did I actually spell that word? Queue, Q-U-E, U-E, like so. And so this queue of programs, the monitor software is pretty clever. What it's able to do is it's able to look at the queue and say, I see that there's a program that needs to get executed. And this software, what it will do is it will load up the code for this program and find the data which is supposed to go with this program and load that in as well and run the program on the data and produce the output. And the monitor is clever enough so that after it has finished working with program A, it is then able to move on to program B without the intervention of a person. The monitor program takes us from here to here automatically. And then once the second program is done, the monitor program loads the next program. And then once that program is done, it loads the next program and runs it until it has done. As well as this queue of programs, the monitor program also is given what are called job control commands or job control instructions that tell it how to handle each program. So these job control instructions would say load program A, load this file of data and execute. And so the program would execute. Then the next job control instruction would say load program B, load program B's data and execute. And so these job control instructions are for the monitor. So the monitor program will know how to deal with the jobs that have to get executed. So this is more efficient than serial processing. This particular approach is called simple batch processing. And it's more efficient because obviously people are squeezed out of the picture. And so since they're not doing work, that makes things go faster. And so this is more efficient. Now, one of the things that sort of comes up because of this is that these job control instructions that I'm talking about, the ones that tell the computer what program to do next and so on, these instructions are restricted. That is to say, a programmer cannot just put these kind of instructions into their program. Because these job control instructions, they control what happens to other jobs. That is to say, for example, if I was a programmer writing a program, I would not be allowed to include instructions to delete other programs from the queue. This person might selfishly say, I don't want to relinquish control of the computer to any other programs. So I'm going to write instructions in my code that delete other programs from the queue so that I can have the queue all to myself. This program shouldn't be allowed to do that. None of the programs should be allowed to interfere with the operation of the other programs that are in the computer that are waiting for their turn to execute. And so one of the things with simple batch processing, and this is still the case today, is that programs, certain certain functions, certain operations can only occur if the program runs in a special mode, which is called kernel mode. Kernel mode gives programs the ability to do anything inside the computer. Whatever you can do in the computer can be done if the program is running in kernel mode. On the other hand, you have what we just call user mode. And in regular user mode, there's certain instructions that are forbidden, that you're not allowed to do. So again, for example, a kernel mode instruction might be to delete a program from the queue, but a user mode program could not do that. Again, that's an operation which is restricted. And like I say, this is something that we still have today. There are certain operations that programs are not permitted to do because they interfere with the basic functioning of the entire computer system. And if you allowed the program to do these things, you could break the functionality of your computer. So certain instructions, they can only operate in kernel mode. And in today's systems, basically kernel mode applies to OS instructions. So your operating system can do certain things, but regular applications, they won't be able to do all of the same things that your operating system would be able to do. So this concept of kernel mode, the concept of a monitor, these things were introduced quite a long time ago now with simple batch processing. But this, as I say, was an improvement over having a human being have to be involved in this sequence of events. All right. So you guys with me on that? Do you guys understand the basic function of this monitor software? And do you guys get the difference between kernel mode and user mode? Any questions about that? Okay, good. I'm sorry that my sketching and drawing on the slides isn't that tidy. It'll be better when I'm in person and I can do it on a whiteboard. But right now I'm trying to write and do stuff with a mouse, and I feel like I'm like 4 years old trying to write with crayons here. It doesn't really work that well. Okay. Now serial processing itself is still not really the fastest way to do things. So for example, if I'm got serial or simple batch processing rather, simple batch processing does only one program at a time. So it can only do one program to completion before the next program can begin. I don't know if I've actually got this in my notes. Let me just see if I can find that. Yeah, I'll come back to this in just a second here. Um, so with simple batch processing, Um, it's kind of like if you have, here we go with our cooking example again. Simple batch processing, the idea is that you can only do one thing until it's complete before you start on the next thing. And you can imagine if it's like cooking and you've got multiple things that you want to cook, but you can only ever work on one thing at a time until it's finished. So for example, if you're making dinner, and your dinner is some sort of pasta dish, you have to cook the pasta completely until it's done before you can start working on, say, the sauce for the pasta. And then only after the sauce for the pasta is done can you then work on making the salad that goes with your dinner. And then only after you've finished working on your salad can you start on making dessert. Like there are discrete jobs that have to be done from start to finish until they're complete. And I think you can see that that would be really wasteful, right? Like if you were really doing this, like if you were making dinner and you had noodles that you were cooking, and you also had to make some sort of sauce to go with your uh, noodles, and you also were going to prepare like a salad to go with your dinner. As I say, cooking the pasta and then only after it's totally done, then starting your sauce and then finishing it totally before you finish started on your salad. Um, I'll ask you guys to type. Um, what's wasteful about this? Like, what in real life this would not you wouldn't want to do things this way, and this would take too long. What would you do in real life that would allow you to do this faster, or allow the whole process to complete faster than what I'm describing here? Uh, use multi-stove, multitask. I think I hear what you're saying, but can you maybe be a little bit more detailed in what you mean there? Yeah, I think that's a good answer there. You can cook other stuff while other things are happening. You can make multiple things at once. Now, what you're saying here, I think, is, for example, you can as a person, you can only do one thing physically at a time, right? You only have two hands and one brain. You can't, um, you know, you can't physically do multiple things simultaneously, but you can start something, and while it is working, while it's cooking, as you've said here, the first thing can keep going while you start on the next thing. So, for example, if you stick these noodles into the boiling water, it's going to take, say, 8 minutes for those things to get ready, say. And during that 8 minutes, you don't sit there just waiting for the noodles to get soft and get cooked. While that's happening, you can start on the next thing. And if you somehow manage to get this thing going before the 8 minutes is up, and this thing takes some cooking time as well, you can even spend some more time working on another aspect of your dinner too. So you don't even really need to have multiple stoves. It's just that while something is happening, you can work on something else. So again, you only have one pair of hands, so you can only work on this, but your stove, your equipment can be working on this while you are doing something else. So we call this multitasking. Sometimes it's called multi-programming, where you have multiple things happening at the same time. So one example of this in real life is working again with input and output. When we ask a program to read information from a disk or to get information from a network, that can take a long time. To download a file can take seconds. To read information from a disk can take, maybe fractions of a second. But while information is being read, that is time where the CPU could be doing something else. So if you imagine, here's your CPU, you're working on your program. Let's call this program A. And let's say that you ask for a file to be read from the disk. And as I say, it could take a long time to do that. And the program A cannot continue until that operation has been completed. And so there's kind of this dead time where the CPU just has to be waiting because this IO operation is in process and program A can't continue. Like, if you're, working on a document, you can't start working on the document until it's been loaded into memory. And so, your word processor program has to wait while this is happening. Well, if you somehow allow the computer to load multiple programs at once, so not only program A, but program B, maybe while the computer is working on program A, program B can't be active yet because the CPU is busy working on that program. But when program A has to be paused because it's waiting for something to happen, again, it's going to take time for this to happen. Rather than wasting the CPU's available time by just sitting there idle, what we'll do is we'll run program B instead. And program B will run And then we can decide to either run program B until it comes to a point where it has to wait, maybe, or maybe we'll just be aware that when program A's data is ready, maybe we should put program B on pause then and return to program A to work on that for a while, and program B can wait for a while instead. So if you look at it from sort of an overall standpoint, the CPU is busy here, and then rather than waiting, it's also busy here. And then again, rather than waiting, the CPU is busy here too. So we don't waste the CPU's time. The CPU is being used 100% or closer to 100% of the time, rather than having to take these breaks when nothing can be happening inside the computer. So the only way that this can happen, as I say, is for multiple programs to be read into the computer at the same time, multiple programs to be loaded into the computer at once. So this is the diagram that's in the notes that talks about this, and it shows three programs, program A, B, and C. And you can see here that program A runs for a while, and then it gets to a point where it has to wait. We call this being blocked because, as I say, program A it cannot continue until something has occurred that it's waiting for. So it's waiting for data to come over the network, or it's waiting for a file to be read from disk, or it's waiting for the user to type something in. While the user is taking their time typing something in, program A just sits there doing nothing because it can't do anything, right? It cannot proceed until the user has given the program some data. So rather than just idly waiting, the computer switches its attention from program A to program B. So program B can make use of the CPU. Program B eventually can get blocked. It could get again to that situation where it's waiting for the user, or it's waiting for information. And so if we have a third program ready to go, program C can start and it can run as well. So rather than program A running and then waiting and then running, so this is all program A, and then finishing before program B starts, and then it has to wait and then it has to run. And then, so that's B. And then after program B is done, then we finally start program C, and it runs for a while, but it has to wait because of the way programs work, and eventually it runs. This program C. So the timeline looks like this: program A first, then program B second, then program C last. And the entire time to execute all three programs to completion includes a whole bunch of waiting time. Instead, if we combine these three timelines, and we run program A for a while, and then during the wait time, we run program B, and then during program B's wait time, we run program C. Again, we minimize the amount of time the CPU is not doing anything. In this particular picture, there's still some idle time, because in this particular part of the picture, all three programs are in the middle of waiting for something, and none of them can keep going. So at that time, of course, the CPU has nothing to do because there's only these three programs and they're all waiting for something to happen. But as soon as one of the programs is ready to run again, it can execute. And if it ever has to wait again, then the next program can execute. So the total timeline is much more compressed as compared to this kind of timeline here, where you do one thing after another. So this is more, as I say, it's more like working in a kitchen where you've got this situation of being able to do one thing, or at least start one thing, and while that thing is happening, you can work on something else, and that makes better use of the resource. So we call this, as I say, we call this multitasking or multi-programming, and this is only with one CPU. This is considering the situation where there's only one processor that's able to do one thing at a time. We're not even considering the fact that you might have a multi-core processor or a multi-CPU computer, equivalent to having multiple cooks. and all of those cooks all working on different things all at the same time, that's going to be even more efficient. But even in the case when you only have one CPU, even in the case where you only have one cook, it's still more efficient to load multiple programs into the computer at once, because, as I say, this person here, the CPU, they're able to move on from one thing to another while they're waiting for something to happen. So in this picture here, this person's waiting for this to boil or waiting for this to cook, and well, instead of just sitting there waiting and doing Sudoku or something, this person is actually working on the next part of the meal. Okay, so does that make sense to you? How multitasking can actually make the computer more efficient, reduces the wasted time of the CPU. The CPU can do other things rather than just waiting around to have stuff happen. Okay, so it looks like for most of you that's okay. It's actually not, I don't think it's a hard concept. Just use whatever kind of picture in your head uh, kind of clarifies it for you, in terms of, again, this idea that the CPU can move on to doing one thing instead of waiting for a thing to complete before it moves on. Okay. One final thing. One final thing that didn't mention here is time sharing. Time sharing is just a slightly different approach from multitasking, in that time sharing refers to the situation where not only do you have a computer which is working on multiple programs at once, but the computer is actually working with multiple users at the same time. Obviously, this is not like with a laptop where there's only one person can use a laptop at once because there's only one keyboard and only one touchpad. But can you guys think of a situation where you have perhaps one computer, but multiple people are using that computer simultaneously? Any examples come to mind for you? Internet cafe, a server. Yeah, I mean, I think it's more like the picture of like a server. For example, um, actually, this is a pretty good example right now. I mean, I'm talking to you guys on Big Blue Button, and my voice and this screen share is going to a server which is hosting this session, and you guys are all connected to that server, and so that is why you can hear me, and that is why you can see what I'm doing on the screen. So that computer is splitting its attention amongst all of you. You're all connected to this one computer. Multiplayer games are the same way. You might have a server where everyone is controlling some aspect of the game, and one server somewhere um, is splitting its attention up between all of you. Another example is like a web server, where a web server hosts a website, and it might have hundreds of people all accessing the server simultaneously in order to get information off of the website. And so that one computer has to split its attention amongst many users, and so that could be an example as well. This semester, actually, we're going to have an example of this directly when we get to the Linux part of our course. What we actually have at Quantlin is a computer. The computer has this friendly name. It's called HAL, HAL. And when you guys are doing the Linux stuff, what you do is you take your computer, and you connect to HAL, and you log in, and HAL will be able to talk to everybody who's connected to it all at the same time. Well, actually, what it does is it talks to everybody sort of one at a time, but it does it really, really fast so that everybody does, no one notices a lag, and it just seems like they have the ability to talk to HAL directly. And so HAL can run programs for everybody simultaneously. So when this program is when this person here is running a program, and this person's running a program, HAL is just switching its attention back and forth quickly between those two people. So they both get the impression that the computer is working for them. And the same thing we're talking about here. When one program is idle, it switches to the next program, and so on between all of the users. This particular server is just for our course. It's not used for anything besides teaching Info 1211. It's the way that we can get Linux into all of your hands to play around with without you guys having to put Linux on your computer. So that's just one example. The university also has other servers that people log into in order to do administrative tasks, like things like course registration and payroll and all this fun stuff that makes the university work. But these servers, they do time sharing to allow multiple users to access the computer's resources all at the same time. And so that's another example of increasing the efficiency of the computer, allowing it to use its resources more effectively by allowing not only multiple programs to get loaded at the same time, but actually allowing multiple people to use the computer all at the same time as well. Okay, we're going to go back to some of that stuff a little bit later on, but I just have one this final slide here about operating system theory before we'll take a bit of a break, and then we'll come back from our break and we'll talk about Windows more directly. So just before we take a break, I just want to say that when software or computer scientists, I guess I should really say, when they consider advances in operating system technology, yes, they improve efficiency, yes, they improve convenience and so on. But sort of from a theoretical standpoint, there are four main advances that, as I say, computer scientists have identified that have allowed operating systems to get to where we are today. And they identify these four key advances as the concept of what are called processes, advances in memory management, information protection and security, and also advances in scheduling and resource management. So again, these four things that are listed here are considered to be the four main things that operating systems have improved in. Four main things that have allowed operating systems to get to where we are today. We'll talk about this one probably the most in terms of what we have time to do this semester. The one key advance is thinking not of programs as jobs to be completed one after the other, but instead of thinking of them in that way, we think of them as units that can be loaded into the computer, and we can draw the computer's attention to them one at a time using multitasking. And as I say, we'll talk more about this starting next week. And this concept of processes allows the computer to manage programs much better. It allows the computer to manage the programs more efficiently and to get more done in the same amount of time instead of doing things like batch processing, like we said earlier. So processes are one thing, and as I say, we'll talk in detail more about this next week. Memory management is another main advance. That is making sure that programs have sufficient RAM memory to do whatever they need to do, making sure those programs do not interfere with each other, making sure the programs cannot affect the security of your system. So that's another main advance. Another one is going to be protecting the information which is in the computer, not only from bad actors, people who might want to attack a system and damage it or steal information from it, but also from the viewpoint of having a computer be reliable and making sure that it functions and that it doesn't lose data, or that the data does not become corrupted in some way. So information protection and security is another important aspect of operating systems. Finally, scheduling and resource management. And again, we'll talk more about this next time. The idea here is making sure that there's a fair way to allocate the resources of the computer to the different programs that you want to run. So if you have 4 programs, how do you make sure that they all get treated fairly, so that one program's not um, just taking up the use of the CPU at the expense of the others, and so on. And so advances in how to actually manage the available resources in a fair and efficient way. That's another thing to consider. If we were taking like an advanced course in operating systems, we would be able to talk about all these things in more detail, and you guys would actually write code that implements some of the basic algorithms that operating systems use to do some of these things. But since this is an introductory course, all we get to do is to just talk about some of these things and what they mean, rather than to get into them in more detail. Um, in terms of like when you would get into this stuff, we don't actually have a course in this at KPU, but at universities that have like a 4-year computer science program as opposed to an IT program, then you would get into like a 3rd-year course in actually building operating systems and writing code for them. So as I say, unfortunately, we don't get into that here, just because our focus is more on usability rather than the theory and development of this sort of thing. Um, Advice on where you could learn that outside of class? Well, you could grab those textbooks, like I said, on the course presentation. There's detailed stuff that's in there. And like I say, if you were doing like a 4-year degree in computer science, those are things that probably that you would be looking at there. Okay, so this takes us, I think, to a pretty natural pause point in our talk today. Yeah. So what we'll do is let's break until 11 o'clock, and what we'll do is when we come back, I'm going to start talking a little bit about the command line in Windows, and talk a little bit about how to use it. I'll demonstrate a little bit if I can. And then what I will also do is talk a little bit about the lab that you guys will be working on this week and the assignment that you guys are going to be working on. And maybe I'll finish off talking a little bit about some early Microsoft operating systems as well. So let's take a break. I'll pause the recording. And in 5 minutes at 11 o'clock, we will begin again. All right. So have a break, grab something to drink, take a stretch. We'll see you shortly. Okay, so welcome back here, and I'll just turn the recording on again, and we can get started. Okay, so what we're going to do now is we are going to continue our class by talking about the command line. And the reason we're talking about the command line uh, in Windows is because uh, I think some people were talking about this earlier. There are certain functions that we need to be able to know how to use the command line in order to actually carry them out. Some of these programs, um, they don't really exist with a graphical interface, and to use them, we need to be familiar with the command line. And it is annoying, right, to have to type in commands. The commands are, have to be spelled properly. If you don't type them in, you have to like retype them, and it's possible to make mistakes, which you can't undo when you're typing them in as commands, and it's all rather can be rather frustrating. But remember this is that 40 years ago, when it was the 1980s, this was all people had to interact with their computers. And it was being done by not only uh, university students who are learning to use computers, but also it was being done by kids who are playing around at home with their IBM PCs and things like that. So it's not something that's unlearnable. It's not something that's impossible to learn. It's just maybe a little bit more foreign to us because we don't use these things as much anymore because we have the convenience of a GUI. So what I'll do is I'll just kind of address um, how these commands kind of came about, and maybe talk about them in the context of the original Microsoft operating systems. And then, as I say, I'll go into a bit of a demo mode here and talk about how these things work. So, the original Microsoft operating system, which came out with the original IBM PC in the basically 40 years ago, 1982. As I say, there were no graphical elements to it whatsoever, and it was all based on typed commands. And this operating system, which was called DOS, it basically went through a number of revisions. And right up until Windows 95 in 1995, DOS was the primary operating system on computers, and Windows, as it existed back in the 80s and early 90s, Windows basically was like a wrapper on top of DOS, which made interacting with DOS easier. But Windows was not really a standalone OS. It was like a interface that operated on top of DOS. It was only in 1995, when the original Windows 95 came out, that uh, the the operating system and interface, the graphical interface, started to be merged together. We talk about DOS because not only because it's history, but because, as I say, the commands that were introduced in DOS are still used today. Like modern day laptops that are Windows laptops use the very same commands that were introduced 40 years ago, and they do the same things that they did 40 years ago as well. Um, these the stuff that's in here, it's not so important that you guys like learn this stuff. It's kind of here just more as almost like trivia, but just a couple of things that are kind of principles that still are true today, even for Windows 10 and Windows 11. Different from DOS. The details are different, but the same kinds of principles still apply. One of the principles is that there are certain files which are what we call system files or boot files. And these contain things like the actual operating system code, which we call the kernel of the operating system. So the kernel of the operating system is responsible for all of the behind the scenes work that the operating system does. It's responsible for multitasking. It's responsible for memory management. It's responsible for process management. All the things that we talked about on the previous slide, those are taken care of by the kernel. We have device drivers, which are used to allow your computer to connect to the various devices that are connected to your computer. So your monitor, your network card, your mouse, your keyboard, your speakers, audio drivers, all those things are part of the operating system as well. And the user interface, so the code which actually allows you to interact with the computer by interpreting your commands. In the DOS days, those files were called io.sys, ms-dos.sys, and command.com, just these three files. In modern Windows, there are not only tens, there are not only hundreds, but there are thousands of individual files which are part of Windows. There are still certain small number of key important files. Those files, if they get corrupted, can result in pretty catastrophic damage to your computer. But as I say, there's sort of still today a core set of files which are system files, which are necessary for the computer. Yeah, the System32 folder in Windows contains a lot of these system files. And as I say, you know, a lot of them, if they get corrupted, they can cause major problems for your system. So another couple of things that you should know is that certain commands are so-called internal commands, and when you type them in, they're just built into the operating system. And those commands do things like when you're interacting with the computer, they allow you to look at the files which are in your directory. They allow you to change your folder from one location to another, and so on. Other commands are so-called external commands. They're not built into the operating system, but they're actually programs that that are separate pieces that are with the operating system. So, for example, when you bring up the command line, and you've got this black screen that you're typing in your commands, certain things that you type, they actually launch other programs to do jobs for you. So for example, there's a program called CheckDisk, which scans your disk for errors. And that is part of the operating system, but we call it an external command because when you type it in, it actually loads the program from the disk and it runs the disk scanner to check on things for you. It's not a built-in thing. It's not like just part of the MS-DOS kernel. It's run as a separate thing. So that's the same way it is today. A lot of commands in your operating system are external. They launch a separate program to do something for the operating system. But some commands are actually built right into the operating system itself, and when you type them in, they execute directly. So there's a lot more information here for you guys to look at. Again, I'm not going to really go over this stuff, and I'm not going to really um, emphasize it. When you guys are studying, you can read this stuff. But as I say, it's just kind of more for me to just include as kind of background information. Okay, so getting to how things are structured in DOS, and starting to parallel it now to the command line. I'm assuming you guys are familiar with using Windows, and so this picture here should be familiar to you guys. It's a picture of the Windows File Explorer, and it shows my computer. And on the computer, it shows a number of different so-called libraries. That's the word for it in Windows. But in my computer, I have a C drive. And so that's my main hard drive, or in my case, it's an SSD. But it's the main storage volume for my computer. And within my C drive, it's got a list of different folders, which are part of things. Now, one of the things that you need to know right away, if you don't know it, is that, oh, and by the way, I'm assuming that a lot of you guys, I'm thinking that a lot of you guys already know and have seen this stuff from like Info 1111 and so on. I know I polled you last week, and some of you said you haven't really done this sort of thing before. Is it useful for me to actually do like a review of the command line? Would you like me to carry on with this? Okay, I'm getting poll results here from quite a lot of you. And it looks like the overwhelming result here is that people would like me to continue with this, so I will. And if you guys have any questions, or if I show you anything and you want to see it again, or if there's something that's not clear, please feel free to interrupt me by just typing in your question in the chat. But otherwise, I'll just carry on here, and we'll see how far we get. Okay, so one of the things that you should know right away is that in this discussion, we'll often use the word directory, and directory means the exact same thing as folder, but folder is kind of something which comes from the graphical user interface world, and directory is something that comes more from the command line interface world. And later on, when we talk about Linux, we're only going to be living in the command line interface world. And so in Linux, we're always going to be talking about directories. Just understand that whenever we say directory, the same idea as a folder. It's a place inside of your storage where you can organize files together, and you can create folders and subfolders. In the same way, you can create directories and subdirectories in order to organize the contents of your drives. And so when we look at the Windows File Explorer and we see these folders, what we're really looking at are a list of directories which exist underneath this particular storage drive. Now, in Windows, when you want to see what's there, you just simply click on the thing, and you see over here on the right-hand side a list of all the things which are inside that thing that you just clicked on. But in the command line, you can't do that, right? Everything is typed. And so if you want to see what's going on, you have to type the command dir for directory. And it shows you a list of the contents of your drive. Now, in Windows, when you click on this, it shows you the contents of this. When you click on this, it will show you the contents of this. The contents of this appears over here. And when you click on this, the contents of this appears on here. We don't really have kind of a way of doing that in the command line, right? You can't like just click on these things because they're not links. So what you have to do instead is you have to navigate the directories by basically walking down into them or walking back up out of them by using a command called cd to change your directory. There's always in the Windows command prompt the concept of your current directory, the place where you're located right now. And that always shows up here in the command prompt right at the very beginning. It tells you that you're located, that your current position is on the C drive in the backslash directory. The backslash directory is the top level of the drive. You guys know, what's another name for the top level of a directory tree? What do we call that? This guy here, the backslash level. 4-letter word, starts with R. Yeah, exactly. The top level of the directory is called the root. And the reason for that is because we kind of imagine that at the top level, the root, below that, there's subdirectories or subfolders. And each one of those things can itself have further subdirectories or subfolders, like so. And so to computer scientists and mathematicians, something that looks like this is called a tree. And so the tree branches out from here into all these other sub branches. And even though the tree is upside down, it's growing from here downwards. We call this thing the root of the tree because everything branches out from the tree like that. So the top level, which we call the root, is signified by backslash. So our current location, what's currently highlighted, we see that right here. in the prompt. And if I type the command dir, it tells us, oh, this is the contents of the root directory. And it shows us there's a bunch of directories. It tells us when they were created. It tells us what time they're created. And it shows us that these things themselves are directories. So the first command, one of the first commands that you should know, super important one, is the dir command. It always tells you what's in your directory. And also the prompt, the thing that looks like this, it always tells you what your current location in the directory is. So that's important thing number one. There's a current directory, and you see the directory here, and there's this root from which everything branches. Concept number two, everything that's stored on your computer has what's called an absolute path, or a full path. And that every file, every item that's stored on your computer has a unique full path, which is different from every other file's full path. And what the full path or absolute path tells us is how to get to that file starting at the root level. So for example, here's my Windows File Explorer again, and here's where Chrome is located in my computer. And this program, to get to it, we can start at the C drive at the root level, and Windows File Explorer tells us how to get there. From this root level, we have to go into the program files subfolder or subdirectory. From there, there's another subdirectory called Google, and in Google, there's another subdirectory called Chrome, and in Chrome, there's yet another subdirectory called Application. This is the list of things which is inside the Application folder, and Chrome is located there. So the absolute path, the full path, says start at the root, then go into here, then go into there, then go into here, then go into here, and then this is the name of the thing. So how we write the full path is like this. We write, first of all, the name of the drive that it's stored on, the C drive. We put the root symbol to say from the beginning, we go into this folder, and then we put a backslash to separate it from the name of the next folder, another backslash to separate it from the name of the next folder, and then another one to separate it from the name of this folder. And then finally, this is the actual name of the file inside this, which is inside this, which is inside this, which is inside this, which is inside of that. And if you want, you can omit the name of the drive letter and just refer to it by this path. And if we know we're talking about the C drive, then we can say, oh yes, on the C drive, this is the path of that particular file. So the full path says start at the root, and then give all the names of each of the subsequent folders and subfolders, or directories and subdirectories, till you get to the actual name of the item. And so, as I say, everything that's in your computer has a unique path because it's stored in some area of the disk, and how to get to there is going to be unique for every single file because of their location. So most of the time in the command line, how commands work is typically when you type them, you type out whatever the command is, and then you type out the thing that you want to do the command on. So for example, do you guys know what the command is that lets you see the contents of a file? So if there's a document and you want to show what's inside the document, do you guys know what the command is that does that? 4-letter command, starts with the letter T. Don't know if any of you guys know it. Okay, so the command to show the contents of a file is simply type, T-Y-P-E. And what you do is you type the word type and then a space, and then you type the name of the file whose contents you want to look at. And what you put in here, if you want to identify the file, you can put in this entire huge long thing. because that will identify the file uniquely. It tells us where to find it in our disk. So if there's a file called, I can see one here in my list. Well, I don't have one, but if there were a file here that was just a text file, we could look at it by just saying type space, and then we could type backslash program files, backslash Google, backslash Chrome, backslash application, backslash the name of file, whatever it is. I think that would be kind of tiring, right? It's obviously going to be tiring for us to do that every time. So what the command line lets us do is it lets us use what are called relative paths instead, relative path. And the relative path, that what we do there is we, instead of saying start from the top of the tree, starting from the root, what we do is we move ourselves into one of these folders. Like we literally navigate ourselves into one of these folders, and then we say from our current position, we say where we have to go from here to get to the thing that we're looking for. So for instance, let me give you an example of that. If I'm just going to erase all this stuff here. If I'm in, let me type this out actually. If I'm in the application folder, the Chrome file is Chrome file's relative path is chrome.exe. Okay, so if that's where I'm located, and that's what this picture is showing, is that I'm currently located in the application folder. And if I'm located in the application folder, the relative path of Chrome is just simply the name of the file, chrome.exe. You don't see the .exe, but since this is an application file, its name is chrome.exe. Now, I can use my navigation ability to navigate to another place. So for example, I could, instead of having application highlighted, I could have the Chrome thing highlighted instead. And so if I'm located in here and not in here, the relative path says I must say what to go into before I can say the name of the thing that I'm looking at. So if, let me just type this out again. If I'm, oh, I have to type, sorry. If I'm in the Chrome folder, the Chrome file's relative path is going to be application /chrome.exe. Okay, so if I'm located in the Chrome folder, the relative path is from where I am, how do I talk about the thing that I'm interested in? So it's one level down into the application folder and then /Chrome. So I do have to provide more information because I'm saying from here, go one level deeper, and from that level, go to this particular location. If I'm, let me just do this one more time. If I'm in the Google folder, the Chrome file's relative path is Chrome /. Okay, if I'm located in this folder, so if this is not highlighted, but if this is highlighted, and I wanted to refer to this file here, the relative path says from Google, go into Chrome, Chrome, go into application, and from there I can refer to the Chrome file. And so in the chat there, you can see that if you're in Google, you have to provide the path Chrome /application /chrome.exe. You do not put /Chrome /application /chrome.exe. And the reason you don't put that is because if you start it off with the /, you're not saying that start from where you are and go down to this folder and that subfolder in that place. You're saying start from the root, right? If your path starts with a backslash, you're meaning to start from the very top level. But if you omit that, you're saying start from where you are and go to where you want to go. Okay, so let me bring this up, and I can yeah, exactly. So if you wanted to go to the absolute path of that thing, you would say C:\program files x86 /Google /Chrome /application /Chrome.exe. Okay, so let me bring this up on my screen here. I'll share my command prompt with you guys so you can see what's actually going on my computer. So this is my actual command prompt on my laptop. And you can see here that I've got, it's gray. You can change the color of your command prompt if you want. The way to change colors is you can click on the little icon in the top left corner, and you can change its properties, I believe. And here you can change things like your screen background. You can see my screen background is gray. You can change the color of your screen text. You can see that I've selected, what have I selected for that? I've selected black for that. And so, like I say, if you want to customize things, you can go ahead and do that. But for some reason, I've changed it from white on black to black on gray. Okay, so if I want to go to my directory as I've been talking about this here, what you do is you type in the cd command, and then after a space, you type in the location of where you want to navigate to. So if you say cd backslash, you can see that the prompt changes to indicate that I've navigated from my starting place to the root of my C drive. If I say dir, you can see the contents of my C drive. And if I say cd, and let's say that I want to go to where Chrome is located, I can say cd program files x86. You can see that it changes one level down. And you can then say cd Google. And you can see that it goes one level down again. cd or Chrome. And you can see that every time I do a cd command, it shows, the prompt shows my location as moving deeper into the tree or further along into the tree. So now I've done cd to get all the way into the application subfolder or subfolder. And if I give the dir command again, dir, you can see that the chrome.exe file is located in there. So this guy here, chrome.exe. I don't know if you can see my mouse, but I can see it. And it's showing there on the screen. So as I say, to get to this place, you can navigate by using the cd command. So I use the cd command one thing at a time to go successively deeper into my tree to get here. But you can do this all at once as well. You can say cd program files. I've got to type a lot of stuff. That's how it works. I can type this, this, this. So you can link all those things together in your cd command, and that way you don't have to go cd, 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 cd. You can just cd all at once, and it gets you to the same location. The cd command has a couple of interesting things that you can do with it. One is that you can say cd ... and that is a short, I don't know, I'll ask you guys, what is cd ... what does this instruction do? It brings you to not the previous directory, because my previous directory before this was the root, right? What it does is it brings me to, oh, some people are typing here. Yeah, it brings me, in this case, it brings me to the Chrome folder. It goes up one level. So right now I'm in program files, Google, Chrome, application. If I say cd ... it moves me up to the Chrome folder. If I do cd ... again, I'll get you guys to answer this question. Yeah, that's right. If I go cd dot dot again, right now I'm in the Chrome folder. If I say cd dot dot, which folder will I end up in? Yeah, so again, if I'm in the Chrome folder right now, cd dot dot moves us up one level. So from Chrome, I move up to Google. And from here, you can go cd dot dot again if you wanted to go up one level, right? So the dot dot allows me to move up. And you can also, whoops, let me move right back down into the application folder. You can also chain together these dot dots like so by putting backslashes in between them. So up one level, up another level, up another level. So this moves me right all the way up to program files x86. So you can also move up multiple levels if you want to. So there's a couple of ways of doing this within the command prompt, the cd, to do that. A lot of the uh, maneuvering of the command line is learning how to work with these absolute and relative paths. And the problem, of course, is that unlike with a GUI, you can't see all this stuff in front of you and how it's laid out. So you kind of have to visualize it in your head. You have to think, oh yeah, there's Chrome, and inside that there's application and so on. Oh yeah, well you can do that as well. But if you aren't starting with the File Explorer, if you're only starting with this, you know, unfortunately that's what you have to do. Okay, now let me just go back to my notes here. Maybe that's helpful. Okay, so there's some examples here of moving around, just like I've been showing you. And here's some questions just to sort of gauge your kind of understanding of these different concepts of absolute and relative path. And as I say, um, understanding that is a real important aspect of understanding how to maneuver around the command prompt. But unfortunately, as I say, you do have to kind of visualize these things in your head in order to sort of understand where things are going. Once you've understood that, there's some basic commands that you guys should know how to use. And again, once you understand the concept of relative path and your current directory, your current position, it makes it a lot easier to understand what these commands are doing for you. So here, the example commands that you should know. CD allows you to change from where you are to another place. So cd backslash Windows backslash systems32, since it starts with a backslash, this is an absolute path, and it says go into the Windows system32 directory, starting from the top of the C drive, go into here, and then go into here. If you don't have a backslash, it means that you want to go into a folder, in this case called downloads, and this folder is located inside of where I am currently. So wherever you happen to be located right now, and again, you can tell where you're located because you'll see in the prompt, it'll say something like C:\\, and then you have your little greater than sign, and then your little underscore cursor. So wherever you're located at this moment, if you say cd downloads, it goes from here down one level into the subfolder, which is called downloads. If I say dot dot, it means move up one level. So wherever I am, go up one level and then down one level into the documents subfolder. And again, it requires you to kind of visualize what's happening. I'm in a particular place in the tree, right? So here's here, here's like so, right? And right now, if this is the root, and say that this is the level that you're at right now, cd dot dot backslash documents means go up one level and then go down into the documents folder, which is like that. So again, kind of visualizing that is helpful. cd backslash simply means go back right up to the root directory and navigate there, from which you can then start moving down into all the other locations. So the cd command, really important. The dir command, also really important. This shows you the contents of whichever folder you happen to be in. So wherever you're located, it shows you whatever is in that particular folder. It doesn't show you all the stuff that's underneath it as well. It just shows you what's at this top level. If you want to show what's all down below, there is a command to do that. It's called tree. And it shows you all of the subfolders that are beneath the current position of where you're located. You can also say tree /F. Anything that has a / in the command line, this is an option. And so if you say tree /F, this is giving the option to not only show the subfolders from where you are, but it also gives the command to show the files as well. So sometimes when you type a DOS command or a CLI command, you use a /. Oftentimes it's a letter. Sometimes it's a word to give an option to the command to tell it how to behave specifically. The copy command allows you to do what it says. It makes a copy of your file. And how it works is you type copy, and then you give the name of the file that you are making a copy of, and then you say where you want to copy it to. So you can say, take this file and make a copy and give it this name. Or you can say, take this file and copy it to this folder. And so it uses the same name, but it puts it in this folder. The folder has to exist. It doesn't make a folder for you if the folder doesn't exist. So if there is a folder called assignment folder and you say copy a1.docx space assignment folder, it'll make a copy of this document inside this folder for you. And you can specify absolute paths. So you can say copy this file to the folder called /users/John/documents. It'll put it into that folder. So here's some explanations for those things. You can create folders, you can create directories using the md command. So you can say make directory labs, make directory info1211 \labs. Again, without the / at the beginning, it means whatever folder I'm located in right now, make another folder underneath it, and it's called labs. Or in this case, make info1211 / labs. It would mean make a folder called info1211, and inside that, create a subfolder called labs. So by using the / in here, it connects that together as this folder and a subfolder. And if you say make directory /users, it means go back up to the root, and then from there navigate down into users, to John, to documents, and then make a folder down in there called labs. So this allows you to do that too. And again, the idea is pretty simple, I think. Make a new directory, but visualizing where it goes, again, you have to understand how these relative and absolute paths work. There's some other commands that you will use, and today when you guys do the lab, you'll play around with a type command, as I said, to show the contents of a file. You'll also use the sort command. The sort command allows you to basically take the contents of a text file, and it sorts the lines of the text file so that the lines of the text are in order, and I'll show you how that works. And yeah, so you'll play around with that stuff. Let me show you the assignment so that you can see what it is that I'm talking about. And as far as the rest of the notes goes, by the way, there's some more information about doing some stuff in DOS. I'll tell you in command line. I'll tell you about this next week. It's probably easier for me to show you rather than to just talk about it online. Here's some stuff about scripting or batch files. Again, not too important for us right now. We'll talk about scripting later on, making little programs of code that can work in the operating system for us. And then also to close off here, there's just some discussion of early versions of Microsoft's operating systems, DOS, Windows 95, Windows 98, and Windows ME. When you're looking at this stuff here, don't worry too much about like memorizing all the details. That's not important for us. I want you basically to read this kind of like a story where you can kind of visualize it as an operating system kind of being born and growing up, and the different kinds of things that happened to it as it grew up, the different things that were added to it, and what happened to it as it matured, basically. And so, how early versions of Windows, they required MS-DOS in order to use them. Um, how Windows NT was kind of like a brother to Windows, and there was Windows and Windows NT that kind of grew up at the same time. There's also Windows 95, kind of the adolescent years of Windows, where it first started to work with plug and play, and where it introduced a new feature called FAT32. And then as it kind of became more of a young adult, it supported USB, and it supported uh, internet protocols so that you could plug a computer into the internet, and so on. And finally, after Windows ME, there's Windows XP, where it kind of grew into adulthood, and it's starting to like be our modern version of Windows that we all know. So yeah, like I say, don't think of this as kind of like a bunch of details to learn, but think of this as kind of like an operating system kind of growing up and the different things that happen to it over time. Okay, let's go to the lab here, and I'll talk a little bit about what it is that you guys are going to be expected to do. So in this, you're basically going to be practicing using a few uh, CLI commands, Windows commands, and they're listed here: cd, md, dir, cls, ren, and copy. And the idea is that I'm going to give you guys steps to follow. And basically, in order to demonstrate that you've done the steps, you'll take screenshots, and you'll put the screenshots into a Word document, and submit the Word document as a PDF um, to show that you've done the work. Okay, so basically it's step-by-step instructions, and if you follow the instructions carefully, you should be okay. A couple of things. Oh dear, it's a bad typo. You must remember. That should say remember. Um, but you must include a space, uh, when you're typing a command, between the name of the command and the thing that you're doing. Make sure you read all the instructions carefully, because you can't undo commands. There's no undo in the command prompt. And if you get stuck and you want to start all over again, just use your File Explorer, delete the folder that you started with, and start again from the very beginning. So if you run into real trouble, you can always reset by using the GUI to delete what you've done and get started again. Okay, so what we're going to do is we're going to get you guys to use the command prompt, as I said. And in order to do all this stuff, we're going to have to get you to create a folder to do all this. And where you create the folder will be in your user account. Normally, when you're logged into Windows and you type CMD and the command prompt opens up, the prompt that you will see, let me just show you. I'll start up my command prompt. The prompt that you will see will normally be inside the users subdirectory. And then inside the user subdirectory, there'll be your username. My username happens to be kenward.48x7vp2. The story is a little long to explain why it's that, but that happens to be my username. Your username will probably say something like c:\users \, and then whatever your name happens to be. So in the context of this lab, what we're going to say is that that folder is called c:\users xxxx. Yep, it's not an activation key. So this guy here, that is what we're assuming your starting directory is called. But of course, it's not going to be XXXX unless that's the name that you use for your user account. If you ever need to get back to here and you're kind of lost, you can type in this command to get back to that starting place: cd space %user profile %. That gets you back to that starting place. So again, if you're really kind of out of luck, you can do that to get back to the beginning. What we're going to have you do is we're going to have you create a folder, a directory inside of here. And that folder is going to be called not XX Lab 1, but it's going to be your initials. And again, everyone's name here is different, obviously. So you substitute your personal initials for the XX here. So for example, if I were really doing this lab, I would make a directory called KC Lab 1. But you make your own directory, call it, PS Lab 1 or AC Lab 1 or whatever the name is, whatever your initials are. If you only have one letter, that's fine. Just use that, like P Lab 1 or S Lab 1. That's fine as well. But you substitute your own information there. Don't use XX. Every time I refer to this in this document, I'll call it XX Lab 1 because that way I'll be consistent. But again, for you, make sure that you're always thinking about what you are going to be using instead. So what you're going to do, as I say, you're going to follow these directions. So how these things are going to be is that you'll see a thing here that says what to do, and then there'll be a little explanation of what it is that you actually did, right? So you guys will be making this folder, and then there's a little explanation about what the MD command actually does. And the idea is that when you read this lab and do it, that you'll do the action, and then this explanation will reinforce what it is that you just did. So the MD command allows you to make a directory, and you type in MD dir name whenever you want to make a new directory called dir name. So this is not saying do this now. It's just saying when you did this, this is what you were accomplishing. So this is the explanation. It's not the step. This is the step that you actually carry out. So after you've done that, what you'll do is you'll type this command in to go navigate into the directory you just created. And again, there's a little explanation that explains, what the cd command does and what it did for you when you did it. And again, all this stuff is happening. It's not visual, so you kind of have to visualize it on the way. And as you go through here and you do these various commands, eventually you'll get to a point where one of the commands you'll do in this case will show something on the screen that looks a little bit like this. And this is just kind of like a little checkpoint just to make sure that you've gotten to this point okay. If you didn't get to this point and it doesn't look like this, then you might have to go back and start it again. That's okay. As I say, there's no undo. Unfortunately, you kind of have to delete everything and start again. But like I say, if you get really stuck, you can always just get rid of the KC Lab 1 or whatever Lab 1 folder you made and just show the contents, or just remake the content starting from step 1. Okay, what we're going to do is then we're going to do another thing where we go inside dir1 and we create a subdirectory called subdir. Keep following the steps. Then what we're going to do is we're going to have you guys use Notepad to create a text file so that you can get some practice with the text files. And so there's instructions here about what to do. Basically, in your Notepad file, you're going to type in some names of some famous people into your file. When you do this, just type in the names just one line at a time. 1, 2, 3, 4, 5. Oh, and your name as well. So that's 6 lines in total. And save this as whatever your name is .txt. So, for example, if your name is Joe, save this thing as joe.txt. And when you save it, make sure that you're saving it into this folder here. And that's so that we can have a common place to refer to it. But I'll let you guys just use Notepad, and within Notepad, when you use save as, just make sure that you save it in this location. And then what you'll do is you're going to grab a screenshot. So to make the screenshots kind of tidy, we'll first use the CLS command. All the things that you've been typing into your command prompt, when you type CLS, it just clears that screen, so it's a little bit easier to read. And then you'll type dir. And this is the first command prompt, the first screenshot. It ought to look basically like this. It should show your directory. It should show the things that you've created. Just like this, and it'll show the name of your file that you made that you typed in the name of some famous people into, and that will all show like that, and then you'll take a screenshot. To take a screenshot, what you do, and let me just demonstrate this. So let's say that your screen looks like it doesn't look like it won't look like this, but let's just say that this is your command prompt that you want to take a screenshot of. What you do is you hold the Alt key down and you press print screen. So Alt plus print screen. And what that does is it copies this window into your clipboard. So then what you can do is you can open up Word. Let me just switch to my Word document here. And in Word, you can just go to paste, Control V, and you can see that this is the screenshot. You should also, just for for my sake and sort of for reference, when you do this, please include a number that indicates which step it is that you're working on. So for instance, this particular step of the lab is step number 7. So you'd put a 7 in front of that command, in front of that screenshot to make sure that it's identified. So let's do that. 7, like so. And also, I should ask you guys to please include like a cover page. So on a page before this, just put, like info 1211 and your name and all that stuff. Right, so then, so that's on page 1, have all that stuff, and then your screenshots can start on second page. One thing that you should not do is when you take your screenshots, don't press print screen only. Or actually, let me show you a couple of things that I don't want you to do. One thing that I don't want you to do is when you do your command prompt, don't make it full screen and take your screenshot of a full screen command prompt. And I'll show you why that is. So I did this sort of behind the scenes here, but I just enlarged my command prompt to be a full screen. And now and I did alt print screen again. And now I'm going to paste it into Word. So here's Word. And here, I did a full screen, and this is my copy and paste. And perhaps you can see what the problem is. Why do you think I don't want you guys to grab a full screen copy of my command prompt when you guys do your screenshots? Yeah, the problem is that the text is way too small, and my marking platform, it's really annoying. I don't have an efficient way of being able to zoom into that. So please don't do that, okay? Don't enlarge your screen to the full screen size. Just take a screenshot with the standard size of things. A couple of questions here, just as I go along. Can I give you a list of commands of the command prompt with some explanations? The answer is definitely that's in the notes, and it's also in the slides. So if you look in the notes, let me just switch you over to that for a second. Here's some of the common commands that you guys will use. And here's a picture of the, where was it? Yeah, so here's this idea, of the current directory, absolute path, and all that stuff, right? And so, so here's your common commands that you're going to be using. And also, if you, I believe, look in the notes. Yeah, it's kind of summarized here, right? So here's the CD command, here's the copy command, here's the MD command that you guys are going to be using. For the Mac, if you guys don't have Windows, you could get into a few problems. You're going to have to end up doing some of the stuff. Ideally, you're going to want to use Windows, and I could get you to use Windows, and I can talk you through that. But let me just say this: if you're using Mac, a couple of things. This is if you're using a Mac and you want to do this same sort of thing, but you don't want to, get Windows set up. The dir command, how shall I do this? The dir command in Mac is called ls. The make directory command is called make directory. The remove directory command is called rm directory. The cls command is called clear. The type command is called cat, like so. And what other command do you need to do? Yeah, it would be nice if you could do that. And I will say that is a great thing for you to do as a student, is to go through the notes and make a summary thing. Isn't that a nasty thing for your teacher to say, is to go through the notes and make your own notes from it? Oh, yeah, one more thing. If you want to delete a file instead of erase, the command in Mac OS is called rm for remove. Other things are the same. Copy, oh, actually they're not. Copy is going to be CP, and rename is going to be called MV. Like I say, ideally, it would be great for you guys to do this stuff in Windows. If you guys were on campus, I would just get you to do this on campus in one of the classroom computers. Just Google command cheat sheet. Yeah, you could do that too. Or like I said, you could just be a student and make the notes yourself. But like I say, if you don't have if you don't have access to a Windows computer, like I say, we'll end up on campus anyway, and you'll do those things there. And later on, we're going to need you guys to know the Windows commands anyway, because because actually what we will be doing in later courses is we will be using Windows, and so you'll definitely need to know that. Oh, where am I? Mac is no good? I wouldn't insult Tim Cook and his dudes by saying the Mac is no good, but I will say that if you end up in a situation where you have a Mac only, you will definitely want to have access to Windows, and there is a way to get Windows onto your Mac, and we'll talk about that in assignment 2, how you can do that. Okay, let me just go back to the lab before I get totally off track here. I've kind of gotten a little bit off track already. Okay, so grabbing screenshots, as I said, make sure that you size the screenshot appropriately. When you are doing the screenshots, like I say, just make sure that you don't end up with a situation where I can't end up reading what you've actually got. The rest of this stuff is pretty much, again, just following the steps. You're going to rename files, you're going to copy files, and in every case, I try to make sure that after I give you the command, that I also give you an explanation of what to do. So here, thing, explanation of what to do, and so on. And at the end, after you've done all this stuff, what you will do, as I say, is that you will take your Word document, make sure that you save it as a PDF, and submit your work on Moodle. And this is due for you guys on Wednesday, January 26th. So next week by 10 in the morning, you guys should have submitted this work. Please don't leave it till the last minute. I know I say that. I know that you guys will think about maybe doing that. Just if you do run into problems between now and then, it's easier to deal with if we deal with those problems earlier rather than last minute, so that you don't end up handing stuff in late. But as I say, this stuff is all just step by step, and so you should be able to just follow the steps. And if you run into problems, major problems, you can always delete your folder and start again from the very beginning if you run into problems. I'll also be setting up a thread, a discussion thread on the on Moodle, and if you guys have questions, you can put them there, or of course you can email me as well. Can you use third-party applications to take screenshots? I don't mind. I mean, Windows has a snipping tool as well. I mean, you can just use the Windows snipping tool. Just the only thing I would say is that make sure that your screenshots are legible. If I can't read them, then I can't really mark them properly. Okay, that's not the only thing for you guys to do this week. There's also a second thing for you guys to think about, and we're calling this assignment one. Assignment one is due in 2 weeks' time, so you guys have a couple of weeks to work on it. And yeah, again, with this, really, it's not going to be easy for you to do this unless you have Windows on your computer. And so maybe I should do a little thing for you Mac users to just talk about how to get Windows onto your computer. Um, let me do that. I'll put that in the announcements area of Moodle, and I'll talk about a way for you guys to get Windows on your machines so that you can do this stuff in Windows rather than on your Mac. So assignment one here is basically short answer questions. And the short answer questions that you're writing, this one is based on the stuff from the notes. This one is based on stuff in the notes. So basically, you read the notes and you write your answers. Don't copy, right? Plagiarism, cheating, that's a big issue in our school for some reason. And if you plagiarize or cheat, you will get marks taken off, or you get zero basically. It's key that you answer in your own thoughts. I say in your own words. And the problem with saying in your own words is I've had students basically copy stuff and then they just change some words. Like they literally take a word like monitor and they'll just take the word and they'll put screen instead. And the problem is that we don't call that piece of software a screen. It's called a monitor. There's no other name for it. So you can't. And what I'll see is students will just copy answers and they'll just substitute words here and there. And that's not your own words. That's copying still. Okay. So what you guys need to do is I need you guys to answer using your own thoughts. Basically, I want you to process it. I want you to think about it. It's almost like you're in an interview. In an interview, you do not quote people, and you certainly do not quote people and just change words here and there. You tell me your own understanding. So in these cases here, as I say, talk about what you think. Don't just Google answers because that's not what I'm looking for at all, and your marks will reflect that. For this question here, this one is talking about two OSs that you have personal experience with. So again, it's not going to do you any good to copy stuff online and say, this is what I have experience with, because it's not you, right? I want to make sure that I'm hearing a story about your own experience with OSs. So you can talk about your experience with Windows 10 or with iOS or Mac OS and so on. So here's a question about that. Question number 4, we'll talk about next week, so we'll just omit that for now. Question number 5, this one has you go to a website and look up some commands. And again, after you look at this stuff and the descriptions on the website, I want you to describe in your own words what these things do. And I also want you to try them out. Again, this is going to require you to do this on Windows, so you're not going to be able to do this on your Mac computer. So that's going to require a little bit of either you go on campus and you try these things, or as I say, I'll help you to get Windows on your Mac so that you can do it that way. This one here allows you to, this one here, you're looking at the registry. You probably won't be able to do this on campus. You probably have to do this on your own computer. So these questions, again, if you don't have a Windows computer, probably won't be able to do. Same thing with number 7. There is a Mac equivalent to this, but again, to learn to do it in Windows, got to have Windows. And this one question here also has to do with using Windows, in this case, the Windows program called ResMon or Resource Monitor. And again, if you don't have a Windows computer, you'll be out of luck doing that one too. So you guys have longer to work on this one because there's short answer questions as well and some stuff that we haven't even covered yet. You guys will get until Wednesday the 2nd to work on that. And between now and then, hopefully we'll meet each other in person and I'll be able to talk you guys through some of this stuff as well. Okay, so just out of curiosity here, maybe I can get you just to type it in. How many of you guys here do not have a Windows computer? Can you just type me into the chat so I can see who you are? Anybody here don't have Windows? uh, you guys are fun. Okay, so if you don't have a Windows computer, can you guys just stick around for a little bit after I close off the session, and I'll say a few words to you and talk a little bit to you guys about how to do that. And as I say, I'll also post something online that helps you to do that. But otherwise, I think we're done for today, so I will call it there. You guys can go ahead and do work on the lab. And next week, we should be meeting in person. So rather than me talking to you and showing my face in this context here, we'll have you guys actually meeting in the class. And so when we meet there, you guys hopefully will have completed the lab, and we can make sure that that's all done, and we'll hopefully be able to teach out the rest of the semester in person. So that's it for today. As I said, I'll stick around a little bit in case any of you guys are Mac users and we have to talk about what to do. And other than that, I'll let you go. Thanks very much for your patience. Thanks very much for staying with us. Where am I? I'm just in my kitchen, but that is just a virtual background. So everyone can get one of these. Okay, so that's it for today. And as I say, I'll stick around for a couple of minutes. For the rest of you, I'll bid you a really good week, and hopefully we'll see each other in person next week at 10 o'clock on campus. Take care, everyone, and have a really good week. Bye now. Okay, so for you guys who are just to answer a couple of questions about sort of how to proceed with this lab. If you have any Windows computer, it doesn't need to be a laptop. You should be able to do it with a Windows desktop, no problem. There is the possibility of borrowing a laptop from KPU. I believe that you can arrange that through the library to get hold of a Windows laptop. The problem there is that after we do lab 1 and assignment 1, it's possible that you may run into some problems working with the laptop they issue, because you don't have permission to do certain things because it doesn't belong to you. So if you are, let me just see if I can browse to this, because this will be probably the easiest way to go.
Excuse me,
If you
Professor.
are someone who has a Mac only and you need, okay, if you are someone who has a Mac only, let me just check again. Who's here right now that is a Mac user? Can you just wait, just indicate somehow at me?
Excuse me, Professor.
Okay.
I am only a Mac, sir.
Okay. So for you guys who are Mac users, let me just type out some information for you guys. So there is a okay. So there is a company called VMware, and they make a software that allows you to create what's called a virtual machine. A virtual machine is like a computer that's inside your computer, and you're able to run Windows in that. So basically, if you're a Mac user, you'd start up this program, and you'd have a window on your screen, and in that window would be a Windows computer. Basically, you're creating a Windows computer inside of your Mac without disturbing the rest of your situation. If you have an M1, could be problematic.
Yeah, sir, I have an M1.
Okay. All right. In that case, Fusion is not going to be an option for you. Yeah, you're going to need Parallels, which is going to be something that costs you money.
Yeah, so I guess it's paid.
Yeah, but like I say, the thing is that you're going to have to be able to run Windows at some point. And so running Windows on a KPU laptop or running Windows on your Mac might require Fusion, might require Parallels to do that. I'm just trying to think here. Parallels for students, unfortunately, even that is like, I think it's like $50 or something like that.
Excuse me, Professor.
Yeah.
Yeah, is it okay with the laptop of i5 processor i5?
You mean like a
No,
Mac with i5?
no, Window.
Oh, Windows.
Windows.
Yeah, as long as
No,
you've got any Windows, you're going to be totally fine. So it doesn't matter if it's an old computer. If you've got Windows 10 on it, then it shouldn't be a problem for you to do this assignment. If you can borrow one from a friend, that's totally great.
like I have a Windows 10 with the i5 processor and 8th generation.
And what? Sorry.
Sorry,
Oh, you said it's got i5 and
8th generation i5.
yeah. No, that's no problem. You can definitely. I'm trying to do two things at the
Like
same time here.
after a few weeks, you said like we can do work of the virtual box. So
Yeah, no, that should still be fine for that. I mean, I've had people use that stuff on lesser machines than that, so you'll be totally fine on that computer. So just go ahead and use that one. That should be fine.
okay, yeah, because
Yes,
I
sir?
have a cap.
Yeah.
Yeah, go carry on.
Yeah.
Professor, I have ordered a hard disk, but it will arrive by a week. So then it would take a week for me to install Windows on my Mac. So is it okay?
Yeah, if you want to do that, that's fine for me. Just
Mm-hmm.
let me know, and that way, when you hand it in, like maybe when you submit it, just put like a comment that explains what happened, so I'll know why it's late, and then I won't take any marks off for it being late.
Oh, okay, I get that. Thank you,
Okay?
sir.
Yeah, that's no problem.
Mhm.
Okay, so who's still here who isn't looked after in terms of getting onto Windows? Keith, are you okay as far as getting access to something to be able to do a Windows lab on? Yeah, that's great. If you can do it, just spin up your Windows machine and you can do it that way. I think you shouldn't have a problem doing all the different things that are required. Yeah, as long as you.
And one thing is more, Professor, like I have a laptop from the KPU. So is it okay, like VirtualBox I have downloaded on the KPU laptop?
That's a good question. I've had some students in the past with KPU laptops, and they were able to install VirtualBox. I don't know if KPU has changed their um, security to restrict you installing software like that.
No,
So
like actually the KPU has given two user accounts. Like one is student account and like for the some other software stuff. So we have to log in a user admin account.
oh, okay, so you can do that.
Yeah,
Okay, and you got this laptop just from the library?
yeah, KPU library.
Okay. Yeah, then in that case, you should be okay. As long as you can use the admin account, you should be able to install all that stuff.
Yeah.
Yeah. Hardik, there's, just in this discussion here, it sounds like there's a possibility of borrowing a laptop from the KPU library. I don't know how many they have, but if you can get
Okay.
hold of.
Yeah, so I'll ask them if they have it.
Okay, because if you can get one from them, that'll make life a lot easier. Azure is this cloud service where you can use computers that are virtual, and that is a partial solution. It might be better for you to have something physical so that you don't have to like worry about, you know, uh, having an Azure account and possibly using it up and stuff like that. So maybe you can look into that. Ah, very good. Thank you. The oh boy. For for Azure, Keith, are you using Azure for students, or do you have like a personal Azure account? Okay. I know that there's also a KPU makes it available for students individually, and there's also the stuff that you can, oh boy, that you can get through KPU. Okay. Yeah, I think that you can possibly try that, but like I say, it's probably better for you to try to get hold of a laptop yourself from KPU if you can. Okay. All right. So are you guys okay in terms of sort of where to go from here? Okay. Thanks for your help, Keith. I appreciate it.